name is Jonathan Wong and my Z ID is 5420721. In this presentation, I'll focus on galaxies by examining their various types, behaviors, and interactions with other celestial objects. Let's begin by examining the two main types of galaxies, spiral and elliptical, using the Coma and Hercules clusters as examples. Spiral galaxies, predominantly seen in the Hercules cluster, usually appear white with well-defined spiral arms and show active star formation. In contrast, elliptical galaxies, which dominate the Coma cluster, appear light orange due to their older stellar populations and lack of gas for new star formation. They form over time through merging events. Generally, elliptical galaxies are older as they've exhausted their star-forming materials, while spiral galaxies continue producing new stars. Additionally, the center of stars of a spiral galaxy are older compared to the younger stars forming in its arms. To understand how galaxies interact, let's examine galaxy NGC 6745. This image provides clear evidence of recently formed young stars, visible as bright white-blue regions in the distorted outer areas. These areas contain hot, massive stars which are characteristic of newly formed stellar populations. This occurs because when galaxies interact, their gravity compresses gas clouds, triggering intense star formation. As the gas cools and collapses, new stars form, gradually reshaping the galaxy and influencing its evolution, ultimately altering its overall structure. Moving on to classifying galaxies, I randomly selected 3 images from the ESO showing a different galaxy cluster, while the last image is from the Hubble Ultra Deep Field. The table reveals that elliptical galaxies dominate 2 of the 3 random clusters, supporting the idea that cluster contain many older merged galaxies. In contrast, cluster 2 has more spiral, indicating that an environment where stars formation is still active. Irregular galaxies are relatively rare in these clusters but appear more frequently in the HUDF, where we see a diverse mix of spirals, ellipticals, and irregulars. These findings are expected as the HUDF looks deeper into space and further back in time, capturing younger galaxies that have not yet settled into well-defined shapes. Additionally, the fact that elliptical galaxies dominate mature clusters suggests that many galaxies will flow through mergers and interactions, consuming the gas and slowing star formation. The HUDF showing a greater mix of galaxy types supports the idea that younger galaxies start as irregular structures and then later on developing into spiral or ellipticals as they mature. If we were to take a photo of the HUDF in 10 billion years' time, it is expected that there will be fewer irregular galaxies, as many will have merged or evolved into more structured forms. Likewise, some of the current spirals may have transformed into elliptical galaxies due to interactions, and overall the universe would contain more passive galaxies with less active stars formations. This means that the distant galaxies we see today would appear much older with fewer young stars, reflecting the ongoing aging of the universe. Overall, this experiment reminded me of the vastness and beauty of space and how a single image can tell us so many things. And here are the references I used.